All right, so quick review of what we talked about today. We talked about the difference between quadratic form, which is this, and we know it's quadratic because it will have an x squared and an x to the first. That's quadratic form. And then we talked later about standard form. We talked about what the graphs look like. They obviously have a vertex, which is a coordinate point. They have an axis symmetry, which is an x equals the x coordinate of your vertex. And then there's a max or a min, depending on which direction it faces. Upward and downward. If it's positive, it opens upward, negative, downward. We graphed the parabola by plotting the points around the vertex. And then we talked about standard form. So standard form only has the x squared. It doesn't have an x and an x squared. It can be, God bless you, it can be in the parentheses like that, or it could have just been like f of x equals 3x squared plus 4. If there's only one x, then it's in standard form. So that would be standard form. You can pull your vertex out of that by changing the sign of follows x and then the k that's by itself. And again, line of symmetry, x equals h. We talked about how to graph using that. So find the vertex, find the intercepts, and if the intercepts are not enough, then you plot some additional points. We actually did this example doing that method. Then we talked about forcing something into standard form, and this was your complete the square. So the complete the square yesterday we did not have a variable, did not have a leading coefficient other than 1. We will do an example today where it does, because your quiz and your test, you will need to know how to do that. And then we took this, we forced it into complete the square, which made it a perfect square. We graphed it. And then we talked about what happens if you don't want to put it in standard form, which is that negative b over 2a. Take it, plug it back in to get the k coordinate of your vertex. We worked through this example. We talked about max and min. If it opens upward, it has a min. If it opens downward, it has a max. Both of them are just k. So prior to this, when we talked about relative max and min, we gave a coordinate point, an x and a y, every time there was a max or a min. With these, there's an absolute max or an absolute min. It is only one number, and it's the k coordinate of your vertex. All right, so we left off here. So we're actually going to work through this example a couple of different ways. So we'll spend a good chunk of time on this example. The first thing I'm going to do is look at this and says identify the vertex and the x-intercepts. Use a graphing utility to verify. So my vertex, I'm going to find using negative b over 2a. Because if you had the choice and there's a number on the front of the x squared, I would probably choose this method. So I would do x, or the h coordinate, equals negative b over 2a, where a is negative 3, b is 2. So I get negative 2 over 2 times negative 3, negative 2 over negative 6, which is a positive 1/3. And that's the x coordinate of your vertex. Good so far. The k I'm going to take and plug back in the 1/3. So I take that negative 3, 1/3 squared plus 2 times 1/3 plus 5. This equals y, which is going to be the k. Y equals negative 3 times 1/9 plus 2/3 plus 5. The 3 goes into the 9 3 times. So this is y equals negative 1/3 plus 2/3 plus 5. I can multiply everything by 3 if you want to get rid of the fraction. Just don't forget to multiply the y. Okay, this time you only have to change one fraction, so it's not that bad. 15 over 3. So I've got negative 1 plus 2, that's positive 1, plus 15, that's 16/3. And that's the y coordinate of your vertex.
Is going to be a lot of fractions?
Yep. Not always, but yeah. Yeah. So what information do you already know in addition to your vertex by looking at your equation? I know the y-intercept, right? Because if it's in quadratic form, these can cancel, and my y-intercept is 0, 5. What else do you know about the shape of your graph? Which direction is it pointing? Down. Which means it has a what? Max or min? It has a max. Now, that all came from my equation from the very beginning. Then I found the vertex. So what information do I use the x coordinate of my vertex for?
For your max.
For, not the x. The y is the max, right? You use the x for?
Well, the x is for your axis.
Axis of symmetry. So the axis of symmetry is x equals 1/3. And the y coordinate of your vertex is your max, which is 16 over 3, or 5 1/3. So all that information you get just from having the equation and the vertex.
The max is y now
Because there's only one point, the maximum value. Before, they were relative, right? So you needed an x and a y because there was more than one of them. Okay, so then it said to find the x-intercepts. To do that, I'm going to plug 0 in for y. And then we have so many options. So one is to factor this, okay? And then even within factoring, you have choices. Because when you have a number on the front, a leading coefficient other than 1, you have two ways of factoring. You can just do trial and error, where I mess with the factors of negative 3x squared and the factors of positive 5, like positive 1 and positive 5. Multiply the outer and the inner together, negative 15x, positive 1x, and see if it equals my middle term. It does not. So then I can switch the 1 and the 5. And now I get negative 3x plus 5x, and this time I get that positive 2x. That's one way to factor it. The other way to factor when you're given a number on the front is using the first and last method, which means you're going to multiply the first term and the last term. In this case, that's negative 3 and 5, just the numeric part. So I get negative 15. Then you're going to find the factors of that sum to the middle term. My middle is 2x, or 2, sorry. So the factors of negative 15 that sum to 2 would be positive 5 and negative 3. Then I replace the middle term with those.
But don't they? Yeah, because like even though 5 and negative,
God bless you.
your answer's going to end up being 3 and negative.
I'm not yet. I'm not ready yet. So I haven't gotten to the point where I can solve it yet. Right now I just replace. So negative 3x squared plus 5x minus 3x plus 5. So I've just taken 2 and I've replaced it with the sum or difference of two numbers that when I combine them back together I get 2x. Then I've got 4 terms, so I'm going to factor by grouping. So from the first set of parentheses, I can take out a negative x, and I get 3x minus 5. Second set of parentheses, I can take out a negative 1, 3x minus 5. Inside the parentheses is the same. And the negative x minus 1 gets grouped together.
Wait, I have a question. Why didn't you do negative x minus 3x and then plus
God bless you.
5x plus 5 so you could put those together?
You could do it in any order you want. It still works.
Okay.
Yep, it totally still works. We just take out different things. Yeah. All right, so notice that the order is not the same on these. This one is different from this one, but what happens when I solve these? I'd get negative 3x equals negative 5, and then divide by negative 3, and I get x equals 5/3, and then set this equal to 0, and I get x equals negative 1. So 5/3, 0, and negative 1, 0 are my x-intercepts. And then over here, I set this equal to 0. I set this equal to 0. I get 3x equals 5. X equals 5/3. God bless you. Negative x equals 1. X equals negative 1. Still the same answers. You do not, obviously, have to do it both ways. But sometimes when you're factoring, you get stuck. And in that case, you can always switch to the second method. Okay? The other thing is that, honestly, I flip back and forth between the two methods based on what kind of numbers my initial numbers are. If these numbers are primes, then I usually do trial and error. There's not a whole lot of options there. But if you get something like a 12 or a 24 where you have to try 1 and 24, 2 and 12, 3 and 8, 4 and 6, what did I miss? That's it, right? Yeah. And then also switch them back and forth, that's a lot of work to do for trial and error. Those, I tend to do the second method. You choose whatever you want to do, okay? And again, if you need extra practice on factoring, because it's not going to go away anytime soon, that there's extra practice on the iTunes U course. So you are going to be responsible for factoring by grouping. God bless you. You're going to be responsible for factoring perfect square trinomials, difference of two squares, or just your standard trinomials where they're not perfect squares. All of them are going to be seen as we move forward because we're going from quadratics into polynomials with higher functions and you're going to higher degrees, and you're just going to keep factoring, okay? The good thing about quadratics is if you are horrible at factoring, you can also always use the quadratic formula. So that's an even third option. Because everything that we're graphing in this section is a quadratic, you can use quadratic formula, which is negative b plus and minus the square root of b squared minus 4ac all over 2a. So a is negative 3, b is 2, c is 5. Negative 2 plus and minus the square root of 2 squared minus 4 times a times c all over 2 times a.
Is there going to be a question on the quiz, like the quiz or whatever, that we have to actually use a quadratic?
Not for this quiz. There's times when we get to real zeros. I think that's like 2, 4, when you're going to have to.
Like you don't have, you don't have.
Correct. Yep. So here I get negative 2 plus and minus the square root of 4. This is positive 12 times 5, positive 60 over negative 6. Negative 2 plus and minus the square root of 64 over negative 6. Negative 2 plus and minus 8 over negative 6. And there's 2 answers here. I get 6 over negative 6, which is negative 1. And I get negative 10 over negative 6, which is 5/3. So any of the ways you do it, you end up with the same answers. So if you get stuck one way, switch. Don't get stuck and not be able to do it. Connor. Sure. So the other thing is there's been times in which we didn't have x-intercepts, okay? 1, those would not be factorable. 2, when you went to use the quadratic formula, you'd end up with the square root of a negative number and you couldn't find it. So one way or the other, you'd find it. Sophia, did I answer your question? Yeah, okay. All right, so all of that was just to find the intercepts, right? And there's 3 options there. You pick whichever option that you want, okay? Zoom in or out? On. Okay. No problem. Okay, then it said use a graphing utility to verify. So we're going to go back to our graphing utility. Again, either your handheld or your app is fine for today, but keep in mind that for your test, you're going to need your handheld, not for your quiz, but for your test. Okay, so I'm going to type it in. Negative 3x to the second plus 2x. What's the Negative 3x squared plus 2x plus 5. And then graph it.
I don't know why when you put the negative...
It's got to be the negative as in
like
that negative.
In the front, but then when it's in the equation...
It doesn't matter.
It doesn't
Yep.
matter?
Nope.
But when I put it on the test, it gave me 2 different answers. So if I put it on the test...
If you did plus negative, it's the same thing as a minus. So it should be the same.
Oh, I didn't put plus that far.
It's trying to multiply it, maybe?
No, but like
Yeah.
I fixed it.
Okay. All right. So from here, we want to verify our vertex and we want to verify our x-intercepts. So remember, vertex is your max. Second, trace gets you to the calc. There's your max. I need to go left of it, which it is right now. It's at my y-intercept, which is left of it. I need to go right of it. And then I guess, and it takes me directly to that point, which is 0.3333 and 5.333. 0.333 is 1/3. 5.3 is 5 1/3, or 16 over 3. Verifies the points we just got. With me so far. We did the max. So 16 over 3 is the same thing as 5.3. You just got to convert that. Then I want to do my zeros. Second, trace, zeros. Those are going to be your x-intercepts.
You did the max before?
I did the max, yep, to get that vertex. So if it's downward, it's the max. If it's upward, it's going to be the min. So now I want my zeros. I'm going to go left of my first zero. Okay, so now I want to do I'm going to go back to my zeros. I'm going to go second zero. I want to go left of my left zero. I want to go right of my right zero, and I want to hit enter, and it's going to bring me again to that exact point, which is -1, 0. Remember, the 0 is just the x value, so it's just -1. We don't write this in coordinate point form. Then I'm going to do that again. Second trace, go to my 0, go to the left of my second one, which is anywhere over here, right of my second one, guess, and it's going to bring me to 1.667, which is 1 2/3, or 5/3. Good so far. All right, if you hit table, so a lot of people operate from table. If you hit table, it gives you only whole numbers. So you got to be careful, okay? So it will give me the perfect rounded numbers, but it's not going to give me my fractions. So that's when you need the other ones. Questions on that one? Easy stuff, right? So you won't use your graphing calculator at all on this quiz, okay? On your test, you will use it, but not for a question like that. You will use it for something different, which when we get to those, I'll talk to you about them. All right, enter in a new paper because we're going to do that entire example using complete the square. Well, not the entire example. We're just going to get it in a standard form. Was it +5? Yeah, right. Yeah, okay. Okay, so again, I said it yesterday, but I'm going to say it over and over again until you take this quiz. On your quiz, you are going to be forced to take something like this and put it into standard form using complete the square. Then you're going to get another question, and that's it. You're just going to put it into standard form. Then you're going to get another question that has an equation, something like this, and it says find the intercepts, find the max, find the min, graph it. For that, you can choose if you want to do -b/2a, and then factor it to get your intercepts, or if you want to put it into standard form. That's your choice. But the first question is going to force you to put it into standard form, which means complete the square. So this equation, yesterday the ones that we did didn't have anything in front of it, okay? So I told you we'd come back and take it up a notch. That's what we're going to do. The first thing that we're going to do is group the first two terms. Then if there is nothing on the front of the x, not even a negative, so only the positive can be there, +1. If there's anything else, we have to take that out. So by taking out the -3, I am dividing this term and this term by that -3. I'm taking it out of the entire parentheses. So I'd get a +x² and a -2/3 x. I'm going to leave my space because I'm going to fill it in, +5. With me so far? Now I got to figure out how to fill that space. So I take my b, which is 2/3, divide it by 2, and then square it. Dividing by 2 is the same thing as multiplying by 1/2. These cancel. I get 1/3. 1/3 squared is 1/9. I'm going to add it inside the parentheses. So this is the other part that's different from before. If I didn't have anything on the front, then whatever I add inside the parentheses, I do what with outside? Subtract it. Normally, I would be subtracting 1/9 over here, right? But because I took out a -3, that -3 directly impacts what I'm adding to the other side, or subtracting from the other side. So before I subtract it, I actually have to multiply it by whatever's on the front. Whatever you do inside the parentheses, you do the opposite outside the parentheses. So because I added, right, I'm going to subtract it over here. But before I do that, I need to multiply by what's on the front. So -3 and +1/9 actually becomes a +1/3. So now I have f of x equals -3x squared minus 2/3 x plus 1/9 plus, and I can keep it as 5 1/3, or I can convert that into a mixed number, 16/3, same thing. Now I force it into a perfect square, which means I can factor it. F of x equals -3, square root of x squared is x, square root of 1/9 is 1/3, sign from the middle, put it in parentheses, and square it. And now my equation's in standard form. So from here, my vertex can be found 1/3, 5 1/3, or 1/3 and 16/3, which is going to match the other information I found. And then I could also find my x and y intercepts by plugging in my zeros. On your quiz, again, you're going to get one question that says force it into standard form, which is this, and then you'd stop. That's it. You don't got to get any other information out of it. Second question is going to give you another equation in quadratic form. You're going to have to answer questions. That you have the choice. Do you want to do negative b over 2a, or do you want to complete the square? Honestly, my advice is if there's a number on the front, especially one that doesn't go in evenly into b, do negative b over 2a. It's probably going to be easier. But if you're really good at complete the square, stick to it. Whatever method it is that works, you want to do it. If it's just asking for the vertex, don't go through all the steps of completing the square. Do negative b over 2a, plug it back in. If it's just asking for max and min, do negative b over 2a, plug it back in. This takes way too long to just get a vertex. Okay, does that make sense? Yeah. All right. Okay, this is the review of what we talked about already, using the graphing calculator to get your max or your min, and then it goes through the whole steps, like a left bound, the right bound, and the max, which we've already done. This is the reverse of what we've been doing. So up until this point, I've been giving you an equation, and you've been getting information from it. Now we're doing the opposite. I'm giving you the information, you're giving me the equation. The good news is this is super easy. So you're going to get given a vertex and a point. You're going to plug the vertex in as your h, your k, the point as in your x and y. You're going to plug it into your standard form, which is x minus h squared. Wait, hang on, I forgot the y. Y equals a times x minus h squared plus k. This is standard form. So when you plug in from the beginning, you will get the x, you will get the y, you will get the h, you will get the k. The only thing left is going to be the a. You'll solve for the a, and then you'll plug back in just the vertex to your h and k and just the a, which means your x is going to be x, your y is going to be y. So they look like this. Find the equation of the parabola in standard form, then graph the parabola and identify the max and min. So again, standard form is y equals a x minus h squared plus k. Don't forget this squared. That's what some people do. Okay? This is your h, this is your k, this is your x, this is your y. Also, don't switch those up because that will give you the wrong answer. So y is 15. A is what I don't know. X is 7 minus h, which is 5, squared plus 12. So common mistakes are people forgetting the squared. Don't do that. 15 equals a times 2 squared plus 12. 15 equals a times 4 plus 12. Another common mistake, and it makes me crazy because you guys are smarter than this, is people will then add these two together. That is not what you're supposed to do. What should be your next step? Subtract the 12. Don't be that person. So I'm going to subtract the 12. I get 3 equals a times 4. And then divide by 4. And a equals 3/4. Now I take and plug back in the a, which is 3/4. The h, which is 5. Don't forget the squared. And the k, which is 12. So common mistakes are the squareds and leaving off the y. You need the y. The y is part of your equation. Now it says identify the max and min. Well, then it says graph the parabola, right? So what's my vertex? 512.
It's still 512. It's 3/4.
That's just how wide it is.
Oh.
That's not going to impact my actual vertex. Yeah. So we're just going to approximate this for the sake of this question, okay? Obviously, we've had lots of practice of actually plotting a point to the left and to the right of that. But for now, I know that this like that, and I know it's going to be open upward, and I know it's going to be wider than normal. Which means, does it have a max or a min? A minimum, and the minimum is what? 12. Questions on that one? So on your quiz, it's not going to have you find the equation and then graph it. It's just going to have you just find the equation. You're going to do lots of graphing outside of that. Okay, here is another calculator example. So this one says the height y in feet of a punted football is approximated by y equals negative 16 over 2025 x squared plus 9/5 x plus 3 halves, where x is the horizontal distance in feet from where the football is punted. Use a graphing utility to graph the path of the football and then answer those questions. So the first thing we're going to do is graph it. So this one's tricky because there's fractions in there. When you type those fractions in, you've got to go to your y equals. I'm going to clear out what's there. I have to put parentheses. So I'm going to do parentheses negative 16 divided by 2025. Close my parentheses. X squared. Oops, not negative 1. Yeah, just make sure you put the negative 16 over 2025, and then the x goes outside. Yeah, make sure you separate off the x. Don't put the x. You can put the x in the numerator, but you can't put it in the denominator. So if you don't put the parentheses, that's what it tries to do. Yeah. Okay, then plus, oops, that's a minus, plus 9/5 x plus 3 halves. And then I'm going to graph it. Does that look like a parabola? No. What's wrong with it? It looks like a line, but so how do I fix it? I got to zoom out, right? And I don't know how far to zoom out, so I'm going to just click zoom out and see how far out I got to go. So zoom out, enter. Wait for it. Wait for it. Still didn't catch it. Zoom. Zoom out again. Enter. So close. I got my max this time, right? But I still don't have my x. So let's answer questions based on this, and then we'll do it again. B says, how high is the football when it's punted? So, and then it even says, hint, find when x is 0. What coordinate point is when x is 0? What's it called? The y-intercept, right? So I can either go to my graph, and actually if I go to trace, it brings it straight to it, okay, which is 0, 1.5. Or that one, you can actually use your equation. My equation's in quadratic form, which means if I plug 0 and 0, my y-intercept's already pretty visible, right? It's 3 halves, or 1 1/2 feet. Because if you've ever punted a football, you're not punting it off the ground, right? You punt, you drop it and punt it. C says, what's the maximum height of the football? So in the zoom that I have right now, I actually catch the max. If I didn't, I can zoom out again, but I do. So I'm going to go to second, trace. I'm going to go to max. I'm going to go all the way up, left of the max, past the max, and I know I'm past it because my y value starts to come back down. Enter. Guess. Yep. Bring me straight to that point, which is 113.9 and 104.0. So what's my answer for the max? 104, right? The y value of your vertex. So 104 feet. Still with me? Yeah. You got to zoom it out? Yeah. It takes forever. D says, how far from the punter does the football strike the ground? So on a graph, what would that look like if it hits the ground? Look at the picture that they give you, right? If it goes up and then comes back down, this is where it's going to hit the ground. What would that look like on a graph? It's another 0, right? It's the second 0 or the second x-intercept. Does that make sense? I'm not on my graph right now, which means I got to zoom out yet again. And it gets teeny tiny. And then I got to find that point. So I go second, trace, I go to 0. I'm left of it already, hit enter. Right of it, and I know I go right of it because my y becomes negative. And then guess, and it's going to bring you to the 0, which is 228.6 and 0. So where does it strike the ground, or how far from the punter does it strike the ground? 220, if we round it, 229, or if it's set to round to the nearest tenth, 228.6, okay? But it's approximately 229 feet. So the max and the min are your y coordinates. The zeros are your x coordinates.